Everyone, it's Mrs. Summer here to talk about how to solve two-step stoichiometry problems. In this example, it says the chemical reaction in this example is environmentally important. Iron pyrite, FeS2, is often an impurity in coal, and so burning this fuel in a power plant produces sulfur dioxide, a major air pollutant. The question is, calculate the mass of sulfur dioxide produced when 3.84 moles of O2 is reacted with FeS2 according to the following equation. So the first step is always to make sure the equation is balanced before continuing. So in this example, the equation is balanced. So first, you also have to figure out, we're going between oxygen right here and sulfur dioxide. So we need to figure out the ratio between oxygen and sulfur dioxide. So oxygen has a coefficient of 11. And sulfur dioxide has a coefficient of 8. So if you remember, the coefficients of a balanced chemical equation are the ratio of moles, not grams. So even though we want to know what the mass of sulfur dioxide, so in the end we want to know how many grams of sulfur dioxide we have, we do need to first figure out how many moles before we can convert to moles of sulfur dioxide before we can convert to grams of sulfur dioxide. So we have 11 moles of O2 is equal to 8 moles of SO2. So 11 moles of O2, remember we can write our ratios one of two ways. We can write it with the 11 moles of O2 on top and the 8 moles of SO2 on the bottom, or we can write it with 8 moles of SO2 and 11 mole on top and 11 moles of O2 on the bottom. Which one do you think we're going to need to use in order to convert moles of O2 to grams of SO2? So here's where I'm going to introduce mole kingdom. Some of you will like this, some of you will not. So in order to convert anything in a stoichiometry problem, we have to go through mole kingdom. So in this example, we are starting in Graham Village, or not, we're not starting in Graham Village. We want to go to Graham Village. But we're starting in Mole Kingdom. We need to go from moles, Mickey's ears, to the other Mickey ear, down the stairs to Graham Village. This is your moles of O2. This is your moles of SO2. And then this would be your grams of SO2. So here's the example of the problem. Now we have a balanced equation. We figured out ratios. We need to map out our pathway. So here is our chemical equation. We are starting with 3.84 moles of O2. We want to go all the way to moles of SO2 and then up to grams of SO2. Remember that the only thing going underneath our equation when we are mapping it out is the mole units. Everything else goes above our equation. So we're going from moles of O2. We need to figure out how many moles of SO2 there are. And then we need to go up to grams of SO2. So they're all 90-degree turns on our mapping our pathway. We can never go as diagonal. You cannot have the hypotenuse. So we're going to remember our arrow here, it's pointing to moles of SO2. So from our balanced chemical equation, we're going to use our 8 moles of SO2 on the top of our arrow. And on the bottom of our arrow, we're going to put what we started with. So moles of O2, moles of O2. So once we get to moles of SO2, we need to use the molar mass of SO2 to convert from grams to moles. So the molar mass of SO2 is 64.07 grams of SO2 equals 1 mole of SO2. So now that we have it mapped out, we're going to place this 3.84 moles of O2 is what we started with. Then remember, we take this ratio and we essentially put it in our next railroad track, because we have to go from moles of O2 to moles of SO2 back up to grams of SO2. And then our molar mass goes here. And since we want grams of SO2, we want our moles of SO2 to cancel so that our final unit is grams of SO2. We want all of the other units to cancel in this example. And then we solve it in our calculator by multiplying the whole top and dividing it by the product of the bottom. And we get 178.93 grams of SO2 are produced when you use 3.84 moles of O2. Now, here is stoichiometry flow map. These are the questions you need to ask yourself every single time you're trying to solve a stoichiometry problem. First question is the equation balanced? If it is, then you can go to, is your starting amount in moles? It won't always be in moles. You may be given grams, you may be given liters or particles. So if the starting amount is not in moles, then you got to go to what units are you given? If you're given grams to start, you need to first use the molar mass to convert from grams to moles. If it's in liters, you can use 1 mole is equal to 22.4 liters, but only if at STP, so standard temperature and pressure. If the problem is not at STP, use ideal gas law equation, which is, if you remember, PV equals nRT. Because then you can convert it to moles. You would be solving for N. If it's in particles, ions, molecules, or atoms, you use Avogadro's number, which is 1 mole equals 6.02 times 10 to the 23rd particles. Then you have to go back. Once you're in moles over here, you use mole to mole ratio from balanced equation to convert from moles of given substance to moles of the substance you want. And then you ask yourself, the next question, is the unit you want to find moles? If it is, you've solved the problem. Remember to write your answer with your number, your unit, and correct chemical formula. Remember, you need a number. Your number is only fully dressed if it has a shirt and pants. If your answer is not, or if what you're wanting to find is not moles, then you ask yourself, is what I want grams? Just like our last example, then you use the molar mass to convert from grams to moles. If you want liters and it's at STP, use the ratio 22.4 liters equals 1 mole. If it's not at STP, you use PV equals nRT to figure out, PV equals nRT to figure out your volume at this stage. And if you want particles, you use Avogadro's number, which is 1 mole equals 6.02 times 10 to the 23rd particles.